I've got this Nespresso C30 mini espresso maker. The owner really likes it. It's been something that's traveled along with her, but it's from the United States and it normally uses 120 volts of electricity. And it was plugged into a 240 volt source directly, which caused a power surge and it failed. So I'm just going to take this apart, get into its power supply, which is most likely where we'll find the components that failed on the board. Did you know that when you travel outside of the United States, in almost every country you go to, you can always find a bunch of repair shops, electronics repair shops? That's something that doesn't really exist in the United States. I feel kind of sad about that. I think there are reasons for that, and I'd like to talk to them a bit about them a bit in this video. Um, but before I do that, you can see the power supply, and you can clearly see that something has burned up on the power supply. So I'm just going to take it off. We'll put it under the microscope, and we'll take a look at it. Okay, when I look at this board, I can only describe this as a hot mess. It looks like some of the pins have blown off of this regulating diode. A couple of other diodes on the board here look like they're very suspicious, and this blue varistor is completely blown. This capacitor with the yellow top also looks very suspicious. I don't think it survived. So I'm just going to remove the pieces that I think are bad off of the board, and then I can test them. What I'm doing here is I'm just gonna add some normal leaded solder. The factory stuff melts at like 212 degrees Celsius, and the leaded stuff around 183. If I mix them together, it'll lower the melting temperature in general, and just to make the removal of these things a little bit easier. And I think what I'm going to have to do is just use a hot air gun, melt the solder, and pull them off on the other side of the board with a pair of tweezers. And now that these are out, I'm just going to use some flux and a wick and just try to clean up the holes, and then we can take a look at the board and look at the components and see what we need to do the repair. And then after the solder is removed from all these holes and we've got the components off the board, I'm just going to use a nano cotton sponge soaked in isopropyl alcohol and just clean everything up. And then I should be ready to repair and take a look at things. As I look at the other side of the board, I see a big problem here. And you can kind of see it where I'm cleaning with the sponge here. It's that hole that looks like there's been kind of a fire, and the word TRAC, which stands for trace, I'm certain. As we clean this up, I'm going to remove a few of the more of the damaged components. But there are some significant problems with this from just a design point of view. And if you see here, there's a chip in the right in the center that has three pins on the bottom, and it looks like one of the pins have been completely blown off the chip. I'm just going to use some flux and some more hot air and pull off the rest of these components. Looks like there's some damage to this little diode. Maybe the pad, it looks like it's ripped off. And yeah, now they're off of the board. And now it's cleaned up. And let's take a look at this. This tracked fuse up here, that is a real problem. But more than that, there's also a pad that says underneath where it says D3 for diode. That is completely removed off the board. So we've got to find some way to replace the copper there. And we've got to deal with this fuse. Now, this fuse is a big problem. And the biggest reason for that is, this is built underneath other components. A track fuse or a fused trace or a necked trace that goes by different names is just a thin track of copper that is on top of a PCB board, and it is kind of a poor man's fuse. It is literally made to catch on fire and melt if there is too much current, too many amps flowing through that wire. I used to think that manufacturers would do this to save the few pennies, and literally pennies, to put an actual fuse on the board. But more and more, I've come to the conclusion that this is on the board for one reason and one reason only, and that is to make the entire piece of electronics, the entire appliance, um, disposable. When this fails, it burns part of the board, and unless you have a repair person that is capable of doing board level repairs and repairing traces, you're kind of stuck. You can try to search for a replacement part, and I did search for a replacement part for this Nespresso for the entire circuit board. I've been unable to find one. They may be out there, but the average consumer will not be able to find them. And if they do find them, chances are this device would end up in a landfill, and the consumer would go find another device. The repairs for this, by just replacing the components and fixing the board, is going to be, I don't know, probably less than $3 or $4 in components. Um, but the manufacturer, in this case, has purposely made a device that is made to fail, and they've done it in such a way that the trace will catch fire underneath other components on the board. That's not safe. It is not something that should ever be done. When you use a track fuse, and to be clear, I don't think you ever should, um, you should be using it in a space that is free from other devices, a place where there could be fire, and the only thing that would get damaged is the board. That is clearly not the case here. Many pieces were damaged, and I have a hard time drawing any other conclusion than this is something purposeful to make certain that if there is a failure of any kind, this entire device gets thrown away instead of repaired. This device is called a varistor. It is sort of like a fuse, but instead of a fuse that blows when the amperage is too high, this is a fuse that blows when the voltage is too high. I think this is K175, is basically a statement saying that if voltage goes above 175 volts, then it starts to fail. Okay, these little diodes, rectifier diodes, are also bad, and this other rectifying, I think it's a diode as well, is also bad. So I'm gonna have to order the parts and replace them. All right, it's been a little bit of time. I've gotten the parts in place. I just want to go through and start repairing this board. I need to deal with this pad and maybe try to figure out what to do with the tracked fuse. Not exactly certain how I'm going to fix it. I'm either going to replace it on this side of the board or maybe put a fuse on the other side of the board. So just want to see if I can expose some of this pad here and maybe put some tin, put some solder on it to tin it, and it's give me the option if I want to run a wire. Although I'm really hesitant to do that. Putting something on here that is also designed to catch on fire is not something I'm thrilled about. So I'm just going to give it some thought and leave my options open. To me, this looks like it is an 18 mil wide trace. 18 mil is 18 thousandths of an inch. And if you were to look at how much current that a piece of wire, a trace that size can take, it's about 4.5 amps. I'm going to replace this with a fuse that is capable of dealing with at least 4.5, maybe 5 amps. I'm going to focus on replacing the pad that has been torn off for this little diode here. I'm going to start by exposing some of the copper, and I'm just going to clean it off really well with some isopropyl alcohol and then tin it with some solder and see if I can add a little square of copper that I can glue onto the board and then use that as the replacement pad. So this little piece of copper has a film on one side. After I tin up these things, I'm just going to use the heat from the soldering iron to kind of melt that pad away and see if that works. Yeah, you can see it's starting to melt here. But I have to say, when you're doing something this small under the microscope, it's awkward. Just going to try to get it to attach, and then I can look at gluing this down. Okay, it's now attached and soldered onto the pad. Just going to clean it up, and I'm going to add just some UV resin, not solder mask, but actually resin to just kind of glue it down. I'm just going to add it to the sides. I just want to make it certain that it's really stable, so when I add the components, it'll keep that connection and not rip off easily. I'm using this white flux. I like it because it cleans easily. Um, it doesn't leave a lot of residue, and I like the way things tin up. have to admit, as I go through this process, I didn't do the best and prettiest soldering job here. It's all very functional. I ended up using this hot air gun for really getting the pads to the devices to stick onto the pads. And in the end, I don't know. I think it could have looked a little bit better, but I hesitate to change it with the damage that was already done to the board. I feel like this is it's functional, it's safe, um, but it's not. It doesn't look like it came directly from the factory or anything. So it is what it is. Um, Heat on the hot air gun right now is around 350 degrees. Um, Tempted to move it up further, but these are diodes. They're very sensitive to heat, so I want to keep it a little bit lower. The air speed is somewhere around 50. I think any more than that, and the components will just kind of blow away, go into what's called the ninth dimension. Um, and after I put these on here, I think I'll try to reflow these a little bit, or maybe I'll just use a hot soldering iron to try to stick the pads a little bit more. It's going to clean it up. Isopropyl alcohol. See what I'm working with here, and yeah, this is just a Kim wipe and a brush. The capacitor, the wooden capacitor, I'm sorry, the brown capacitor, the square plastic capacitor seemed tested okay. So I'm going to reuse it, replace these other components, the varistor and the other electrolytic capacitor. They are all through hole, so I'll just add some flux on the other side of the board. And I'm just going to use my soldering iron. Again, I think that this is at 350 degrees Celsius. Has been using it more. I've been kind of experimenting with different temperatures. I think that 350 works, but I think it might go up to like 400 for my J tip on my soldering iron and see if that works well. I think I'm getting to the point where I can do things a little bit more faster, and what I'm looking for is just kind of a quick movement on the board that doesn't affect too much of the board. A little bit of a solder ball here. I'll see if I can get this away with just the iron. Just clean the tip, and yeah, it's not so bad. Okay, all right. Just gonna clip off the remaining wire. Uh, Sometimes these little wires I could use for something else. I've used them as jumper wires before. So here's the board. Again, the soldering job is not that great, but it is definitely functional. And all the components are here. The only thing that's going to be left is the trace, which I believe what I want to do here is I'm going to put a fuse on the back of the board. I think that's going to be the safest option. It's not going to cause a fire if there's any problems. It'll work at least as well as it used to. And I'm just waiting now for the fuse to come in. It's probably going to be another couple of days. All right, I've got the fuse. This is a 5 amp surface mounted fuse. And I'm just going to mount it on the other side of the board. Use some flux, some solder, and I think if these are connected here, this will take place of the tracked fuse that was on the other side of the board. Worked just fine on this side, and I believe that this is a much safer option. This fuse cost, I think, somewhere around 8 cents in total, and so I imagine that if a manufacturer were to buy these in bulk, they could probably buy them for much less money or find another solution that was just of similar design where they're using a fuse instead of a narrow part of the board. And it's in place. I'm just going to start putting everything back together. This is adding on the wires that supply power to the control board here, and we will see if we can save this device. and it's alive. Everything seems to be working. Coffee's made, and thank you for joining me on this journey.